Hello, everyone, and welcome to the Canadian Electricity Association's Conversation webinar series. I'm Dave McKendry, Senior Fellow with the Canadian Electricity Association. I'm pleased to be your host for today's session. The CEA has worked with our corporate partners to develop this conversation series, which focuses on solutions to current and future challenges faced by our industry. Today, Wood PLC will be presenting severe weather and climate change risk in Canada's electricity industry. Severe weather risk to energy assets and operations is evolving with the changing climate. To respond effectively to this challenge, utilities must rely on ever-advancing information and tools to support decision-making for both operations and planning. In this webinar, Jonas Roberts, who leads Wood's Met, Ocean, and Digital Environment Solutions team, will give an overview of weather risk communication tools and climate analytics and assessment services developed and offered by his team, with a specific focus on utilities and the energy industry. Before we get started, please feel free to type in any questions into the questions section of the webinar tool, and we'll get to those questions at the end. We'll be sending out a copy of this presentation after the webinar, along with a post-webinar survey. We would certainly appreciate your feedback. We're also interested in any topics that you may be interested in as a part of this conversation series. With that, Jonas, we'll now ask you to join us on screen, and we'll turn the webinar over to you.
Thank you, David. And just want to confirm that you're able to hear and see me okay?
Yeah, we're good. Thank you.
Excellent. All right, so PowerPoint has been a little bit finicky here, but I'll just continue on as if everything was normal. All right, so as David mentioned, today I'm going to be covering some topics related to severe weather and climate change risk in Canada, specifically as it relates to the electricity industry. I'm not going to be focusing too deeply on the specific risks that they pose, but more talking about how we can identify those risks and mitigate them going forward. So as David mentioned, my name is Jonas Roberts. I'm based out of St. John's, Newfoundland, in Eastern Canada, but our team is spread across the country with several locations. So the motivation for this talk, and the motivation really for the development of many of our services, is to help clients understand and mitigate weather and climate risks. Now, severe weather and climate change impact nearly everyone and everything, and this really allows the electricity industry, among others, to adopt strategies and resources and tools from elsewhere. You don't have to be starting from scratch. You're not the first people to be looking at this problem. So there is a lot to discuss. I could spend several hours on pretty much any of these topics. So I'll do my best to keep things on time, but please do forgive me if I geek out a bit and go on a short tangent. But of course, happy to explore in more detail during the Q&A at the end, or in any follow-up conversations you wish to have. So before we get started, just a little bit about Wood. Okay, and PowerPoint's not working great, so I'll just go through the old-fashioned way. Wood is a global leader in technical, environmental, and engineering and project services. We have a footprint pretty much all across the world. Well over a century of experience with our predecessor companies, 60,000 people operating in 60 countries and generating about $10 billion in revenue. Now, this webinar, I'm going to be focusing more specifically on services offered by my team, the Met, Ocean, and Digital Environment Solutions. And this caption here sums it up fairly well. We are severe weather experts who help mitigate risks from high impact weather events to infrastructure, facilities, and operations, any time of the day, any day of the year, anywhere in the world. Now, while our service offering is global, our core clientele are based here in Canada, and we are, in fact, Canada's largest private industry weather service provider. Now, these are just a very high-level overview of some of the specific service offerings that we provide. This webinar, I'm going to be focusing primarily on the top row, things including forecasting and alerting of severe weather events, climate change, vulnerability and risk assessments, modeling and risk communication, climate change projections, extreme weather quantification, but we'll also be touching on some of the satellite and remote sensing data, as well as the information management capabilities and some of our oceanography modeling as well. Must apologize again for PowerPoint. So just a bit of context, as I mentioned, pretty much everything and everywhere is affected by extreme weather. Sorry, folks, just give me 1 sec. I'll see if I can't get this sorted. I'll just rely on this. Pretty much everything and everywhere is expected to be impacted by climate change. Apologies. And the electricity industry is not the first to experience this. And just a quick Google will give you some idea of how many weather newsworthy events there are across the country in a given year. This slide literally took me like 5 minutes to put together. There's no shortage of headlines related to how climate change is impacting our lives, how severe weather is impacting individual communities and regions across the country. Things like Canada's extreme weather could be the new norm. Power utilities forced to adapt as climate change brings wilder weather. Municipalities and utilities on the front lines of extreme weather. There's no shortage of these from everywhere across the country at any given time of year for all sorts of different weather hazards. Like you to focus a little bit on the bottom one there. The severe weather in Canada, cost $1.3 billion in insured damages just last year, and that's from the Insurance Bureau of Canada. Now, as we dive into that a bit more, we can see, across this is where the actual slides would have come in handy. Basically, this is the top 10 list for years of insured damage losses in Canada, and 8 of those 10 years, 8 of those top 10 happened in the last decade. You see things that you'd be very familiar with, like the fires in Fort McMurray, the floods in Alberta and Toronto, the Quebec ice storm. But it's a wide variety of different hazards that really lead to these major insured losses. Just zooming in a bit on last year, 2019, you see a variety of things. The first half of the year, you're looking primarily at winter storms, but there's also floods and hailstorms, hurricanes and other windstorms that happened. And just wanted to, these pictures here, I just wanted to give everyone an example of some of the new challenges that we find ourselves dealing with. These are pictures from Snowmageddon, which happened in St. John's in January of this year. We received about 3 feet of snow in one go. The entire city was shut down. Actually, yeah, Danny, it seems like if you want to take over the slides, that'd be great. But just kind of speaking to this, this one event, the 2 slides, or the middle picture there, that's the door to our office that we had to shovel out. It had an 8 or 9 foot drift in front of it. The picture on the right is me trying to clear my driveway. All right. Okay, Danny, let me know when. Okay, you can see there well. Okay, okay, looks like we're back in action. Yeah, on the right is me trying to clear my driveway after the event. For a bit of context, I'm 6'4". There was a lot of snow around, and the image on the left is our one of our main roads that circles the city. So we're dealing with in unprecedented times, and we're having to face challenges that we haven't experienced before. Next slide, please. So going to give a bit of an overview on of some of the trends that we're seeing happen across the country. This is historical trends. They're not necessarily extreme events, but more on the intense side. So first, we're looking at precipitation, and any of the upward pointing triangles are showing an increase, and downward are showing a decrease. You can see that in general, it seems like there's a bit of an increase in extreme precipitation. But it varies a lot from region to region, and whether or not those trends are statistically significant or not. Next slide, please. Now looking at temperature, these trends are a lot more consistent across the board. On the top row, we're seeing increases in some of these warm weather indices, and in the bottom, we're seeing a decrease in a lot of the cold weather indices. Something that you might notice is the scale on the bottom, the legends on the bottom row, go up to about 30 days. So we're looking at substantial shifts in how the year pans out with regards to weather and climate in much of the country. Okay, next. So that's a very, very small taste of the recent past. But the next part of this webinar is all about looking forward years and decades. This is about getting ready to and ensuring long-term resilience of your organization. So we're going to start off by looking at some climate projections. In general, there's kind of three main things that all the science and all of the models really strongly agree on in a truly global sense. The first is temperatures are increasing. They've been increasing for decades. They're going to continue to increase for decades to come. The next is that the hydrologic cycle is intensifying. The general rule of thumb is that dry areas like the Southwest and prairies are getting drier, and wet areas like the Eastern Canada, the mid latitudes are getting wetter. The reason behind this is that as the atmosphere warms, it's able to hold more moisture. So while you may not be getting more storms coming in, the storms that you do get are able to draw on a much higher amount of moisture in the atmosphere. So you're more likely to get extreme precipitation. And the third is sea level rise. Now, all of this is on a global basis, keeping that in mind. But these are three things that there's very little doubt and very little disagreement with regards to what's happening. But looking at local impacts is something different altogether. This is where you get a lot of disagreement between the models. You get a lot of discrepancy between regional impacts. Some things that you might be looking at considering are small versus large temperature changes. Most of Canada will be seeing a sea level rise, but in fact there's going to be some regions where we'll see a relative sea level drop. Some places will have wetter climates, some will have drier climates, some will see wetter and drier climates. As well, the frequency and severity of extreme events is going to be changing, or has been changing as well, as is the timing of seasonal change. Next slide. So this is as deep as I'm going to get into the specific climate change impacts that we could see across the country. There's temperatures are increasing everywhere. The figure on the top right gives an idea of how our temperatures are evolving with regards to the rest of the world. We're seeing a temperature increase at about twice the global rate, with the Canadian Arctic actually seeing about 3 times the global rate. Relative sea levels are rising on the Atlantic and Pacific coast, but decreasing around Hudson Bay. That's because the land is still bouncing back after the last ice age. So as the land is rising, the sea level is rising as well, but not as fast as the land. So you're starting to see what appears to be a sea level drop. Heavy precipitation events are more likely. The bottom left map shows potential increases that we expect to see by mid-century. But we're also going to expect to see increasing droughts, particularly in Western and Central Canada. So those are locations where you're seeing the wetter and drier climates going forward. We also can expect to see reduced snowpacks in extent, in duration, as well as the snow water equivalent that they're holding. And as well, specific to the east coast of Canada, we can expect to see more intense tropical cyclones. Not necessarily more tropical cyclones, but the ones that we do see, will be drawing on warmer ocean temperatures, and they will be stronger as they go through, and they will be able to travel further north than they have in the past. Next, please. And this is really just a quick overview of some of the work that we do in characterizing historical climates and projecting future conditions. We do everything from resource assessments of renewables, whether it's wind or solar or hydro. We quantify extreme weather both in the past and future, and this could be everything from frequency curves or return periods. So what's your 100-year event? What is the risk of a project or asset specific threshold being exceeded in the future? Things like probable maximum precipitation, which I'll talk a bit more on in a bit. And uncertainty and risk estimation. This is something key that's often overlooked in a lot of the discussions that go on about climate change impacts. I mean, predicting the future is a tricky business in general, but when you're looking out, 10, 20, 30, 40, 50, 100 years in the future, there's going to be a lot of uncertainty, and being able to capture that uncertainty and quantifying it in a meaningful way, so you're still able to take action based on the information, is something that we spend a fair bit of time on. So it's a lot of it boils down to customized projections and analysis. There's a lot of great tools and resources that are available online. They typically focus on the more common parameters, such as things I showed you before, like your temperature variables, your precipitation. But a lot of our clients have more bespoke needs. And what we do is we really take that complex data and turn it into actionable insight. Next slide. And so there are literally dozens of ways to represent and communicate climate projections. It really depends on the data you're working with, the agreement of the climate models, the types of variables you're looking at, as well as the region that you're looking in, and of course the needs of the end user are paramount. When we're looking at the top row there's an example of a wind resource assessment we did for southeastern England, and the map on the far left is the ensemble average. So we took 20 climate projections, and this is what the average of all of them showed. Now, taking an ensemble approach is always important because different models show different future climates, and you're never really quite sure which one is the most representative. So it's important to capture a lot of different models. But in this case, it showed something that was a little different. It showed, wind speed was decreasing over the water, but increasing over land. And when we looked into it, there wasn't really a physical explanation for this, and it was more a quirk of kind of the statistical averaging of the ensemble. So what we actually did was break it up into having multiple narratives. So we found that a lot of the climate models agreed that there was going to be a general decrease in wind speeds, and a lot of models also agreed that there would be a general increase in wind speeds. And both are equally plausible scenarios, and both help the end users understand what the risks or what the uncertainty associated with planning a wind project in that area could be in the next 30 years. Now, the bottom plot, or the bottom row, is from a study we did for the government in Nunavut, looking at changes in water temperature with respect to their fisheries. And what these maps show is model agreement. So in general, when climate models tend to agree, you can have higher confidence in what the projections are telling you. So it's important to have an idea, a good understanding of where those models agree and where they disagree. So in this map, you could see that any of the cross-hatched areas, that shows where all the models showed that there would be a warming of the water in the coming decades. And areas without the cross hatching, there was more disagreement, and so you'd have less confidence in those areas. Next slide, please. So I didn't go into a lot of detail on the specifics with respect to climate change across Canada, but hopefully you have a bit of an appreciation for the types of things that we'll be dealing with. So just going to talk about what some of those risks actually mean with regards to considerations for the electricity industry. Starting off with increasing temperatures, you'll be dealing with additional challenges with regards to equipment deterioration. A lot of assets and equipment are designed for specific environmental loads, but those operational loads are evolving and changing. This will impact your operations and maintenance needs. You're going to see larger line losses in your transmission and distribution networks. The efficiency of your thermal plants will be impacted because any of the cooling water that is brought in will be starting off at a higher temperature. It's also going to impact demand. In warmer winters, you won't have as high of a heating load, but in warmer summers, you're going to have a much higher cooling load. So when we look at things like precipitation, dam safety is probably one of the first things that comes to mind for any hydro operators. They were designed largely based on historical climates, and a lot of those extremes may not hold true going forward. But on the flip side, there's also the risk of lower water levels. You might not have enough water to fill that reservoir to be able to generate enough electricity. there's also increased flood risks, not just at your locations, but also all across your supply lines and any transportation networks. There's a lot of seasonal shifts that you can expect, as I alluded to, but also ecosystem shifts, which are important to monitor, because there might be some of your assets in kind of borderline sensitive locations, and the sensitivity of those ecosystems may be growing in the years and decades to come. So it's important to keep an eye on those things. Also, with extreme precipitation, you have issues with slope stability and increased washouts. Now, when we're looking at extreme events, there's a whole new range of risks that get brought in to pretty much any type of infrastructure, depending on the event and location. It's going to have increased demands on your operations and maintenance. It's going to change when you see peak demand from your clients, as well as things like forest fires. In Western Canada, we've seen a significant increase in the number and the duration and the extent of forest fires. And as I alluded to earlier, supply lines. So it's not just the impacts on your specific assets and your specific operations, but there's going to be things that impact your supply lines from all over the world, which should be accounted for as well. Next slide. So now it may seem fairly obvious that one needs to have at least some kind of understanding and prepare for these climate risks. But here's a diagram that helps kind of drive home the message of the benefits of doing so. So we have two different types of situations: option B on top and option A on the bottom. Option A is kind of your status quo, your business as usual, no real resilience efforts have been put in. And option B is if there's been an investment in making your assets and your operations more resilient. Now, assume that the same external shock, so it could be a big storm or something, comes into play. In option A, you're going to have a significant decrease in your performance and your level of service that could last for a significant amount of time. But for in option B, where you have those resilience measures implemented, the initial drop in level of service won't be as significant, and you'll be able to rebound to your business as usual case more quickly. And of course, there's always the risk that a non-resilient system may never get back up to that same level of service as before an event. There's a broad range of benefits for incorporating resilience, even if climate change wasn't happening. You're going to minimize any health and safety threats, as well as threats to the environment. You have a better understanding and more stability when it comes to financial and business risks. And also specifically with regards to reputation after and how you respond to a disruption event. This is something important and something key. Nobody expects anyone on this call to be able to control the weather. Everybody understands that weather is getting weird, and we're starting to experience things that we haven't seen before. But how your operation actually responds and rebounds can really dictate the opinion of your organization for many years to come. Next slide, please. And so this is an example of, or just one way of illustrating how adapting to climate change can work. And so if you just scroll through this slide, please, Danny. You can take a look at a flood event that might have a remote chance of occurring, but would be catastrophic in its severity if it did happen. Climate change is going to very likely increase the probability of that event. So if you don't want to still have catastrophic consequences for that type of event, then you have to put some kind of adaptation measures in place. And so that will bring down the severity of the impact of that event. So while climate change often dictates the probability, we typically have a respectable amount of control over the severity of the impacts of that event. And it is really the probability times the severity that gives us the overall picture of risk. Next slide, please. And so there really are very many ways to evaluate the climate risk to your facilities and operations, and there are several frameworks that can help you develop adaptation plans. I'm only going to introduce and discuss one of the more recent and more common approaches, and that's the climate lens assessment. This was introduced as a mandatory requirement by the federal government a couple of years ago for anyone seeking to avail of $10 million in federal infrastructure funding or more. It typically consists of two components. One is measuring and quantifying the anticipated greenhouse gas emissions impact of the specific project. And the other is looking at the risk assessment and mitigation of the actual climate impacts. So in order to do the second portion, we adopted the PIBC protocol. This is from Engineers Canada. Their Public Infrastructure Engineering Vulnerability Committee developed this risk assessment protocol about 15 years ago. And this is where you take a look at the climate impacts, you look at the different climate hazards, you know, in the chart on the bottom left, those are across the top row, and then the different components of your system that could be impacted. And then look at the probability and severity across all of those, and it gives you an idea of where the highest risk within your system, your operations is going to be. And then from that, you're able to propose or develop or investigate further some mitigation measures. So these are very high level. These are, you know, fairly quick turnaround, really just to ensure that people are considering climate change in some way. But you're able to dive much deeper, you know, depending on what your specific needs are. And you know, on the bottom right, there's just a few examples of CLAs that we've conducted for energy clients over the last couple of years. Next slide. All right, so still on the theme of planning is understanding what the your worst case scenarios. This is particularly important for infrastructure whose failure would have catastrophic results. So those are things like dams and nuclear facilities predominantly. So I got 3 slides really talking about some of the work that our team does in this area. The first is related to hurricanes and coastal impacts of those hurricanes. This is, you know, we can do things like high resolution simulations of historical or even hypothetical worst case storm scenarios by, you know, changing the storm tracks and their intensities. And, you know, the 3 images here, those are from some work we did for Puerto Rico, modeling hurricanes Irma and Maria, which were 2 Category 5 hurricanes in 2017 that occurred within a couple weeks of each other. So this is where you can see what, you know, the potential, what your water level is or significant wave heights. And you're able to couple these results with terrestrial flood models, which we did for the British Virgin Islands in a resilience study from last year. And so this is particularly important for East Coast infrastructure, where we see, you know, the tropical storms coming into play and impacting us. Next slide. So potentially similar in impact, but very different in origin is tsunamis. And this is perhaps more of a West Coast concern, but still very much a risk in the Atlantic. You know, this, you know, can look at trigger events, everything from subduction zone earthquakes to submarine landslides to terrestrial landslides that go into the sea. So again, like it's important to understand what height and volume of water you might be seeing come towards your operations. And of course, now all of this is compounded with the need to consider sea level rise. So any of these circumstances are compounded by rising sea levels going forward. Next slide, please. So moving from saltwater to fresh, looking at your worst case precipitation or what's called your PMP, your probable maximum precipitation. A lot of jurisdictions require you to design to full PMP values and some just a fraction of those. So what we do to determine what the worst case storm could look like is look at all of the storms that could, have happened over a basin, and then look at how bad they potentially could have been if, you know, the atmospheric conditions align just right. So we take a bad storm, we make it worse, and then we take the worst of the worst for given duration and area, and you get your PMP results. So this, you know, these figures are from a study we did for the U.S. Army Corps of Engineers a few years ago. And just one example of a storm that actually happened while we were doing the study and had a tangible impact on the results of our study. This was a 1 in 1,000 year event in Monroe County in Louisiana. They received over 2 feet of rain in 2 days. This was in March. In October of that year in southeastern Louisiana, there was another 1,000 year event with another 2 feet of rain in 2 days. And all of this kind of feeds into our studies. And so the image on the bottom there gives you an idea of the level of precipitation from a worst case scenario event over a basin in Arkansas, which is just north of Louisiana. And so there we're looking at, upwards of 34 inches over a 3-day period. So you get an idea of kind of what the atmosphere could actually do to your location by doing these types of studies. Next, please. So up until now, I've been focusing on the long term and the planning. But for the rest of the talk, I'll be talking about how we quantify and communicate with weather risk in real time and in an operational way. Next, please. But the first step is to give you some insight into our operation. This slide shows the flow of information from the installation of real-time monitoring equipment on site to the high-frequency collection of data to modeling and forecasting severe weather to communication with clients. Clients have online and mobile access to recent forecasts and warnings and are able to call and speak directly with forecasters on a weather desk 24 hours a day, 7 days a week. There's a couple key things about this that I'd like to highlight, and that is kind of the ellipse in the middle. We do all of our data storage and processing and a lot of our transmitting of communication materials in the cloud. That really provides a level of resilience to our operations as we're not, we won't succumb to any kind of specific extreme event that happens in any individual location. An additional resilience measure in our operations is that we have 2 fully operational weather offices. We have one location here in St. John's and another in Ottawa, and both can operate fully independently and autonomously. And that ensures that we never have any downtime in our operation, and we haven't to date. Including during the Snowmageddon in St. John's. As I said, we had an 8-day state of emergency here, and we had 0 downtime. And also at the beginning of the pandemic back in March, because we host all our services in the cloud and don't rely on local services, we were able to transition to remote delivery at the beginning of our pandemic. It only took a few hours of planning, and within a couple of days, all of our forecasting operations were fully operational remotely. One other quick thing on the previous slide is AWIPS 2. That is our forecasting engine that we use. This is this was developed by the U.S. National Weather Service. It's the state of the art in graphical forecasting systems. But something that I always like to brag about is that deploying it in the cloud is a feat that the NWS has yet to achieve. So we're fairly unique in our capabilities there. Okay, thank you. So it's also worth taking just a minute to expand on some of our remote sensing capabilities, particularly from satellite information. In the last few years, new generations of satellites have been launched, along with additional computing power and capabilities, particularly our in-house analytics and machine learning capability. This has really opened up a treasure trove of new insights across a range of applications, spanning both planning and operations. And I could spend several hours talking just about this topic, but for now, we'll just leave it there with some of the examples that are on the screen. Next slide. Now, this is the last slide focusing exclusively on the back end of forecasting. This is a specific example where the synoptic scale systems, so like your high pressure systems, your low pressure systems, are not well resolved in are usually sufficient for some kind of public consumption forecast, but there's often situations where your operation may be in a fairly unique geography that has fairly specific risks. For this project, we were supporting the construction of an offshore platform here in Newfoundland, and it was being built in Bull Arm, which is kind of like a fjord type geography. And the 15-kilometer resolution of some of the publicly available models, it wasn't really going to cut it for the wind forecasting there. So what we had to do was downscale these models first to a 2.5-kilometer resolution, and then just click through once, please. And then ultimately to a 200-meter resolution. And this was operational forecasting that we provided. And so, you know, on the figure on the far left, what was represented by just one wind barb in the public models, you know, really kind of was able to be downscaled into much finer resolution and insight, as you can see in the image on the far right. Next, please. So now shifting over to electricity and supply demand, just going to start off with a pretty commonplace example. This is something that happened last year in Ontario. It's, you know, all very commonplace, nothing extreme about it. You know, there was a sunny afternoon when power demand dipped by, you know, over 1,000 megawatts when a storm moved in, reducing air conditioning demands, and then, you know, the solar output dropped because of the cloud cover, kind of in parallel with that. And then the next day we saw a significant bump in wind generation capacity because another storm front moved in. So, you know, this is nothing extreme. This is nothing out of the ordinary that happens, but could have significant financial implications. And knowing what to expect in the coming days, both from a supply and demand perspective, can help reduce those risks. Next, please. And so on this slide, I'll just talk a bit about, give an example of those types of services for forecasting both supply and demand across Newfoundland. You know, we do forecast for the wind farms here in the province. This consists of 7-day forecasts of wind speed and direction and temperature and air density, as well as alerting of any conditions that may impact power generation, such as wind power ramps. We also do forecasting for the 6 hydroelectric reservoirs across the province. There we generate twice daily 7-day precipitation forecasts for multiple locations in each reservoir. Danny, if you can just click through, please. As well, we also forecast demand for 9 key load centers across the province. You know, similar types of forecast variables, and related to these, we also do monthly and quarterly accuracy reports. Now we can work with clients to produce production forecasts. You know, so actually forecasting what the power production will be specifically, or some clients would just prefer us feeding them the information from the weather forecasts, and then they develop the power forecast themselves. So it really depends on what the client systems are and what their sensitivities are. Next, please. But of course, it's not just about predicting the supply or predicting the demand. Weather is also having an increasing impact on our day-to-day operations. You know, severe weather could be affecting access and infrastructure, such as, you know, severe lightning events, you know, creating conditions for flashover and insulators. Also for physically accessing your sites, and whether it's, you know, winter storms or whether it's from floods. You know, some of the ways that we can help provide insight into more of those transportation type challenges is through our road weather information systems. We do a lot of work for departments of transportations across the country, as well as down in the States, as well as road and rail transportation companies. But we're finding now that more and more asset owners and managers are availing of the service, because, you know, it helps with the planning of winter maintenance. You know, if you have a lot of parking lots to clear, or, you know, if you have some long access roads to get to your locations, it's important to know, you know, when to send trucks out to clear those roads, or how much salt or what chemicals to put down and when. So it's not just about, you know, again, the extremes. It's people use this information to help their day-to-day operations run more smoothly in the span of a given year. Next, please. Now, how clients receive information from us is also important and different depending on users and needs. And this is just a small sample of those. You know, sometimes it's as simple as a 1 or 2 page PDF emailed out a few times a day. But it could be something a lot more interactive and you know, graphical representations on mobile devices or via the web portal. Some clients want confidence intervals or real-time observation data feeds. Others are more interested in summarized severe weather outlooks over the next week or 2. So, you know, we always work very closely with clients to ensure that they're getting the right information that they need in the way that is most easily digestible for them, and in a very timely manner. Next slide, please. So many of our clients use our services to ensure that, as I mentioned, that they operate efficiently and safely. But there's also, an increasing need to understand the specific risks to your assets and operations. Decision View, which I'm showing here, is our primary approach to this. This really allows users to quickly view the range and degree of weather-related risks for multiple locations. We use a traffic light system that intuitively allows users to quickly and comprehensively understand if any of their specific operating thresholds are at risk of being exceeded. This is all built on an in-house risk engine that aggregates several sources of uncertainty and models and data sources. So, it kind of negates the need to check different sources of information, as it's all accounted for in the specific user profiles. We see this really as the future of forecasting, and I have a couple more slides to focus on that. So the previous view, you can see on the slide, spans a very broad geographic area and just gives an indication of aggregated risk levels of each. But then here we zoom in on a specific location, and just as an example for Ottawa, and this is a mock-up. I do realize that it is a very lovely day in Ottawa today, and there is not a risk of snowfall. But just gives you an idea of the type of information that could be displayed. So you break it down by specific hazard, and you get an idea of when the timing of that hazard exceeding your operational thresholds may be exceeded. Next, please. Now those are for discrete locations. We can also set this up for segments of road or rail or your transmission and distribution infrastructure. Next, please. And also through the portal in which this is displayed, it also allows for spatial animation of the forecasts, but also of the specific or aggregated risks. So on the left is just some model data with regards to a temperature forecast, and on the right, that map is a region surrounding Toronto, which shows a progression of the spatial risk. This is the aggregate form, which incorporates anything that's predefined, so whether it's wind risks or temperature or precipitation risks. This is just kind of shows all of those combined, and you can see how the risks evolve over time and throughout the region. So this will give you really that broader understanding of the risk as it comes in to impact your operation. Next, please. And it's also very customizable by users. This includes, you can add or take away locations within a given region. You can add in new hazards, modify the thresholds for those hazards, and also tweak the sensitivity of the risk engine, so that figure on the bottom right. We added this functionality in because everybody assumes they know what risk means, and so we want to make sure that the people are able to tailor this to be as fitting to their intuition as possible, so they're able to more effectively and quickly make those operational decisions. We can also set up, or users can also set up specific alerting settings via text or email. So that's really what I wanted to cover today. I realized it was all fairly high level and very quickly ran through a lot of content. But what it really boils down to is these 2 points here. Weather risks are evolving with climate change, and Wood is well positioned to provide risk-based decision-making support for planning and operations, regardless of what your needs are. And so, David, that's it for me. So I'm going to hand it back over to you there now.
Well, that's terrific, Jonas. I'm always caught by the intricate detail that goes into our industry. It doesn't matter where you touch it, and where technology certainly reaches into places that we may not typically consider where we need to be or want to be as a utility. Just quickly recapping, we learned about, obviously, weather changes are happening all the way around us. We only need to look out the window. But thank you for articulating and drawing our attention to the significant changes that are happening even here in Canada. We heard about increasing temperatures and the impacts on things like equipment deterioration, OM&A needs, line losses, thermal efficiencies, and demand changes. We heard about changing precipitation and, you know, the ramifications of dam safety, lower levels of water, flood risk, slope stability, and revenue impacts, certainly, and obviously extreme events, infrastructure risks, and toppling of towers and whatnot, again, increased OM&A. There are a number of challenges with the weather for certain within our industry. For those viewing, if you'd like to take a moment just to ask a question to our resident expert, Jonas would be happy to answer your questions. We do have some questions, Jonas, that have come in. But I think if I was summarizing it, with all these changes, how do we as a utility reduce our risk to the business? That's the underscoring a challenge. And it's kind of interesting, as you were talking, I was reflecting, you know, we can't change the weather, we can't change the wind, but we can adjust our sails. And I think what I'm hearing, it really comes down to planning. Do we take an active or do we take a passive posturing on this side? And I'm learning that start with information. Expert information that's beyond just looking out the door. And we heard about some of the capabilities where other utilities and organizations are taking advantage of monitoring, analysis, forecasting, and reporting. So we can explore any of that. If you've got some questions, we'd be happy to field them. I found it very interesting as you were going through. In fact, I smiled, Jonas, amidst all the changes in weather and whatnot, that your data storage and processing is in the cloud. as much as it kind of caught me, I thought, wow, that's a juxtaposition, but certainly we definitely understand the benefits of going online for sure. So to our questions, and again, if you've got a question, just tap it into your webinar screen. The first one is, so how far in advance, Jonas, can Wood see into the future in terms of weather impacts? You know, whether somebody simply watches the Weather Network or beyond, what's the value add beyond that where Wood can provide benefits?
So with regards to kind of timelines, there are very kind of physical limits to how much skill you can get out of a forecast, a weather forecast after a certain amount of time. You know, certainly the closer you get to an event, the more detail you can provide about it. But we, you know, typically for clients, we can provide, you know, 1 to 2 week look aheads with regards to potential severe events coming in. And so that's where our forecasters look at kind of what the atmospheric setup's going to be that could potentially trigger an event. An excellent example of that is that the hailstorm that impacted Calgary there just a couple of months ago. We were able to identify that risk 8 days in advance. And that is, you know, significant considering that a lot of the publicly available forecasts were barely even hinting at it the day before. So this gives our clients that much more lead time to get any kind of long lead preventative measures in place.
Huge benefit there.
No, it's incredible, and you know that's, you know, a lot of the publicly available forecasts. You know, with you know any number of weather apps that you have, many of those are just automatically generated, pulled from the you know, the publicly available data and aggregated in some way. But we find that particularly with extreme events, the actual having the forecasters involved in producing the forecast, we were able to quantify that it has a significant value add. The clients are able to make decisions much further in advance with much more reliable information there. We do also provide kind of seasonal outlooks, but typically you're only going to get the kind of, there's a chance that it might be more or less than normal type information there. But you know, that still could be valuable for planning.
Great, thank you. Next question was related to, so what's the process you use to engage with customers? What's the approach you use?
So it really depends on the customer. I think that, you know, if someone approaches us for our services directly, then, you know, we're able to have that initial conversation, understand what their operations are, understand what, you know, kind of weather impacts they've seen in the past, or you know, what information could be useful and helpful to them going forward. Sometimes, you know, we respond to kind of public tenders, and you know, things are very prescriptive, and we just outline either how we'd meet those needs or make recommendations on different ways to kind of still meet the client's overall needs. But regardless of what it is, it's important to, you know, have those initial conversations with clients to make sure that everybody's on the same page with regards to, you know, what the ultimate goal is, and what information and how that information is delivered to help clients meet those goals. But you know, it's an ongoing process. You know, we deliver a lot of validation reports to clients on a monthly or seasonal basis. You know, we make sure that clients are able to literally contact us at any time of day or night, any time of the year, to talk about any of the forecasts that are coming in. So even if, you know, an event is coming, you know, kind of coming down the road, that, you know, clients may not have the right information for it, they're able to call us and ask us questions about that, so they're still able to make the right decisions.
Great, thank you. Next one up is how do you price your services?
Situation by situation, really. It depends on, you know, the geographic extent. It depends on how related to our other services we provide. So take, for example, you know, our RWIS networks. You know, we do forecasts all across the country for, you know, road weather and winter maintenance. But it's, you know, it's a relatively straightforward matter to add new clients using, you know, kind of the standard RWIS forecast template for those. So in that case, we're able to price things a lot more, or I guess a lot lower, using those economies of scale. But you know, we do have a lot of clients that have very specific weather needs that require us to develop specific systems to be able to meet those needs. And in those cases, there would certainly be some premium pricing associated with it.
Great, thank
But
you.
it could be
Next
anything
one.
from, sorry, just to elaborate a little bit more, it
Yeah.
could be anything from a day rate, a monthly subscription type approach, or even on an annual basis. Like we're happy to work with clients to make sure it works for everybody involved.
Great, thank you. That's very helpful. Thank you. Next one was, are there any specific resources you recommend to get more information about climate change impacts? Anything to avoid or be careful of?
Yeah, so as I kind of alluded to, there are lots of great online tools and resources. I mean, a lot of smart people have put a lot of effort into making this information widely accessible to the public. Specific to Canada, the climateatlas.ca is very intuitive and fun to play around with, and gives you a good overview of your, you know, various precipitation and temperature variables. And you know, you can get some site-specific information from there, and that's very reliable. Another is, you know, the University of Western Ontario has a extreme precipitation intensity duration frequency tool, which is great and pan-Canadian as well. So I suggest looking at those for flood risk. But you know, I guess when it comes to things to avoid, it goes back to what I mentioned about ensembles. Be very, very skeptical of any report or any study that only relies on a small number of climate models. If it's one or two models, I would not trust the results, frankly. It's not actionable information. It's ignoring a huge amount of uncertainty. You know, and if you're only looking at, you know, a couple of models, they might be the outliers, you know, either in a positive or negative sense, and really misrepresent what the future could actually hold, and any number of potential equally plausible realizations.
Great, thank you. And next one was, climate adaptation is clearly important, but equally important is climate change mitigation, reducing greenhouse gas emissions. And do you have any specific recommendations on that front?
Well, I think we have a great audience here. I don't have to mention the focus on more renewable power production. I think, you know, that everyone on this call is certainly making great strides in that direction. But you know, there's a lot of measures that kind of overlap the resilience and the mitigation sides of things. You know, kind of green resilience in some circles. And these are types of things that would allow you to reduce travel to different locations. So that's where things like remote sensing come into play, where you're able to monitor and a lot of times even control remote operations without actually having to have a physical presence there. So that reduces your emissions to and from. And it also kind of along a similar vein, setting up what's called a digital twin. So having a computer model, of the environment as well as the assets, and that way, if you want to make any significant changes, you're able to make those changes in the models and actually understand what the downstream impacts would be without actually having to invest all of a huge amount of effort and materials and capital in investing in something that may or may not be a sure bet.
Certainly makes sense. Just monitoring the time, we're approaching the top of the hour. Again, Jonas, this has been a fascinating topic. It's the weather's all around us, we all experience it, but to the extent we're trying to hit that holy grail of if we can at least anticipate so we can adjust our sails a little bit in advance, there's some huge benefits. So we appreciate your presentation. We appreciate understanding what wood can do to assist in that regard. And with that, we'll thank you and allow you to jump off camera. And Danny, if you wouldn't mind, just to the next slide, please.
Thanks so much.
Thank you. So with that, our next corporate partner conversation series webinars will be held on November the 12th. Burns and McDonnell will be presenting fleet electrification, moving past pilot implementations. This webinar will be of specific interest to your key accounts, operations, and asset management staff. Basically, anybody who's dealing with electric fleet implementation, whether it be within the utility or dealing with customers that are going through the implementation of an electric fleet. Also, on November the 17th, Eaton will be presenting Fleet Management for Intelligent Electronic Devices. This webinar will certainly be of interest to your IT, asset management, and operations teams. All of CEA's future events and webinars can be found in our monthly newsletter, Current Affairs, or you can go to the news and events section of our website at electricity.ca. With that, thank you again for joining us today, and until next time, bye for now.